Good morning, friends. I am Professor M. H. Chennaiya, and in today's video, we are given the orthographic views of a cubical block, and we are required to draw the isometric projection using these three views, namely the front view, the top view, and the left hand view. Friends, if you observe these dimensions, you have 60 as the length, 60 as the width, and height is also 60. So very obviously it is going to be a cubical block. And now friends, let us construct a cube on the isometric axis using the dimension of 60 millimeter. That is to say, friends, I will just write a line, and on this line I mark a point. From there, I take these dimensions as 60 on all the sides. So, height is equal to 60. The length is 60. The width is also equal to 60. So, I will mark 60 here. Finally, the height of this is also 60. These dimensions you can compare with the dimension, the orthographic views. Remember friends, in isometric projection, we are going to make use of the isometric scale, and whatever the dimensions you have got here are to be multiplied by 0.815. So here whatever I have written here, these are all isometric dimensions, whether it is a length or a width or a height. ISO means it is 60 into 0.815, it will be around 50 millimeter. Friends, now let us see how to obtain the isometric projection of this component or the cubical block. Friend, this is the front view you have got. And in the front view, if you observe, you can see there are three vertical rectangles. So front view I am going to mark in this direction, that is F. So you should be able to get three rectangles here. So whether it is a vertical rectangular face in front of you or an inclined surface in front of you, it appears as a rectangle only. So friends, the overall dimension in the front view is 60, and that is split into three parts. So each is equal to 20. So 20 ISO, 20 ISO, 20 ISO. So I can just draw thin line through all these. This is 20, this is 20, and the height is equal to 60. So friends, we have got these three lines, 20 each. And similarly friends, if you observe the top view, there also have got three rectangles. So I am going to divide the top face into three equal parts. So only the cubical box I have written just to make the concept simple. Friends, if you observe from the end view, there is a line inclined at 45 degrees to the opposite square actually. So this is 45 degree. So friends, I can just join these two by a straight line, having length is equal to the diagonal of that square. So we can have one line here. And friends, at the extreme end you have got another surface. So friends, what we can do, since this is seen as a rectangle of width 20 and height 60, we can take this point and this corner and just join these two to the bottom face. So friends, we are going to have this join to the bottom face. So this is one line, this is the other line you get, and these two lines form an inclined surface. Because when you see in the end view, that is in the left hand, you should be able to see that. So friends, I can even complete this vertical line representing this and the bottom line representing this. Friends, this is the surface and that surface is represented by, this surface is represented by this one. This is the sloping surface. So this first one is sloping. Similarly friends, there should be another such sloping surface, so that when you look from this side, that surface should be parallel to this or in line with this. So friends, what we can do, this is at the extreme end. So I will take these two corners and again these two corners, and I am going to join them so that you are going to get one more later on. We'll see how to do that. In the center, friend, you have this bar. So what I can do, I can just obtain the front view of this, that this rectangle here, another line from here. Friends, this will give you this bar, this vertical rectangle. And friends, we will join this to this and again this to this. And friends, this, if you observe, this is going to be the top face of this line is represented by this. And friends, if you observe very closely, so friends, this is one surface. There should be another surface similar to this on the extreme end. So friends, what I can do, I can just write a line through this point parallel to this. Friends, not like that, parallel to this surface means it will go little up. So something like this. Friend, what are the line I have written here is parallel to this. That means to say, you are going to have one more such surface there. So instead of that, to make it more meaningful, we'll say that we are joining this to this. So it will go little up, if I am right. Yeah, this is to be parallel from there. So if you continue this line, it will touch this, friends, and we'll complete this drawing. And friends, if you can see here, after this line when continued will also seen as a line here. That is to the last line. So when you look from this side and you have got this line, one line covered here, the other line will come somewhere here. Yeah, it has to be. So friends, this is how it will look, friends. Now this surface is in line, in plane with this. So friends, let us join all these points so obtained by visible line. And now to make the drawing look beautiful, let us remove all these construction lines. So I will remove this line from here. Again, I will remove this line so that you will be able to visualize the object in a better way and it becomes easy to understand also. So let me remove this line also, and this line is to be removed, all construction lines. So without removing the construction lines, your drawing will never look beautiful. So you can have a small line here to show that these are inclined at an angle of 30 degrees. That is, both these lines, the length and width line, are inclined at 30 degrees to the horizontal. Friends, let me draw bold lines through all these. Remember friends, finally after completing this, you should say it is isometric projection, because we have used an isometric scale to construct this figure on this isometric axis. Friends, now I will finally explain to you how these different parts appear. Friends, in the top view, you should see three rectangles. So friends, this is one such rectangle. This is the second rectangle here. So I'll just make it look nice. Okay. Second rectangle, the last one is the third rectangle. So three rectangles we have got. In the front view, we have to see three rectangles. So this is one rectangle, this is the vertical second one, this sloping surface is a third rectangle. And in the end view, that is in the left hand view, you can see friends here, there is this sloping, so this line is represented by this surface, this rectangle here. Similarly, the one which is on the other side of this are also represented by this. So this one, this rectangle and this last rectangle, they will be on the same plane. Hence you are going to see only one line for that. And friends, this vertical line here, this vertical line, whatever you see here, is this line in the plane. Friends, whatever the figure we have drawn, that is the isometric projection, has to be compared with the orthographic views of the component given. Check them once before you say it is completely correct. And I have shown you that we have obtained the isometric projection of a component whose orthographic views are given. And remember, this drawing is made using isometric scale, and whatever the dimensions we have marked here are multiplied by, that is 60 into 0.815 is this. Similarly, this side it is 60 into 0.815, and even the height is 60 into 0.815. Friends, I hope the presentation was interesting, and if you like this video, do share this video with all your friends, and have a wonderful day. This is Dr. M. H. Chennaiya signing off.